Hey class, wanted to run you through our first homework assignment. I'm going to do page 112 here. Then I think I'll split them, do them all separately. So you'll get a 112, a 116, a 119. We're skipping 122, and then I think it's 124, or is it 126? Anyway, I'll do all the work from the packet, and I'm going to try to do the review guide too. And I'll get those all up in the next few hours. And you'll be able to look at them tonight, tomorrow night, to be ready for a quiz that I think is still going to be Tuesday. I know I threw around that maybe it would get moved back to Wednesday, but I don't think so anymore. Looks like it's going to be Tuesday for sure. So just study, do your work, ask me questions Monday. You'll be good. I'm sure you'll be fine. Let's get into it. So the first question here is about how to do dilations by hand, and we talked about a couple of methods for that. So the first method was, well, actually, no matter what method you use, you're going to want to draw a straight line from P through whatever point you're trying to dilate. So I'm going to go from P through A first. Now, if you've got a ruler, you can certainly just use your ruler. So you grab your ruler, you line it up with P, you angle it so that's lined up with A, and then with your pencil you just draw a line. Ooh, that's thicker than I wanted it to be. So from P, go through A. Now our scale factor is 2. That means the original distance from P to A should double to give us the distance from P to A prime. So you guys can see that the distance here is looking like 34. So double 34, we're going to want to go out to 68, which puts us here. Can put a little dot there. I'm not sure I'll see it. No, I didn't see it. So I could change the color of the dot. Maybe we'll make a blue dot at 68. Puts us there. So now I can see that blue dot just barely, but I can darken it. So right there should be A prime. So that's the first method we could use. I'll show you the other method too. Now the other method still starts by using a straight edge. I'm going to go up and we're going to dilate point C. So again, I'll use my pencil. We'll make this line in blue, doesn't matter. But once I've got my pencil drawn, your other method was to take your compass that you should have. I gave all my kids compasses. Hopefully you've got a compass as well from Ms. Lee. If you don't, you can ask me for one. But basically we use our compass to set the compass. See how we can swing it back and forth? But we're going to set it so that it's right on C. And then we know that if this is the distance from P to C, then the distance from P to C prime should be this distance doubled. So it's like you can imagine swinging from P once. Then you go to the end so that your little pin is on C, and then you swing another arc, and that shows you that the point that's twice as far away is right here. So that point is C prime. Just one more time though. If we just used a ruler, that's fine. You can see that C is at basically 50. And if you double 50, then you can see that our new point should be out here by 100, and it is. So that's all good. So again, we can do B. And honestly now, if you're using your ruler, you don't even have to draw a line, because we can see the distance to B is, I'm going to call it 47. Doubling 47 gives you 94. So if I put a point at 94, then I know that's my point. And I don't really need the line, because the ruler is acting like my line. But that's going to be point B prime. Now we need D prime. So again, put the ruler at P, pass it through D. I'm getting a length of about 54, 53. So I should go out to 106 or 108 or so. So I'll put a dot right there. And that's going to be D prime. So after you've labeled all your points, you can take your straight edge again and connect the dots. I'm going to cheat and just use the computer's built-in straight edge. But we want to go from C to B, we want to go from B to A to D, and D to C. So what you should see is a shape that looks exactly the same as the original, just bigger. We talked about how the corresponding sides should appear parallel, and they do. That feels right to me. And of course, all the corresponding sides should be twice as big. So you guys should be noticing that C prime, B prime is twice as long as CB. Well, that's it. That's how you do a dilation. Okay. So for number 2, They want us to dilate again, but this time they want us to be chopping these distances in half, which is fine. I think I would still just use my ruler. I'm going to line up the 0 point of my ruler with P and measure. It looks to me like it's about 55. Let's call it 54. Half of 54 is 27. So you know we just want to make a mark at 27, which is right here. So I'll make a mark. Then I can spin my ruler over to A. And A is looking like it's about 75. Half of 75 is going to be half of 75, 36 and a half, 37 and a half. All right, so go to 37 and a half. Yeah, close enough. I'm not looking for perfection. But both of those points right there, those points should do it. So I'll take my straight edge drawing tool and I'll draw a nice line connecting these guys. And I'll label them. This one is supposed to be A prime. This one should be B prime. And again, what you should notice is they're parallel. And A prime, B prime should appear shorter now because we've got a scale factor that's less than 1. Scale factors less than 1 always shrink the pre-image, and you end up with an image that's smaller. You should also be noticing that it's half as long. I don't know if it's worth it, but sure. Let's actually just measure and you'll see all the distances we found were half as long. So let's see if our length is half as long. So that looks like it's about 70. You should expect this one to be 35. And look at that, it's 35. So we know that we did it right. I'm going to move on. For number 3, it says find the center of dilation and tell whether the dilation is an expansion or a contraction, and tell the scale factor. Okay, well, to find the center of dilation, we said just connect the corresponding points. So you just want to pick up your ruler and draw a line from A through A prime and give yourself plenty of room for the lines to intersect. Then go to B, do it again, draw a line from B to B prime. And that point right there where they cross, that should be the center of dilation. They're asking us to name it P, so I'll name it P. If you're wondering why I didn't draw a line from C to C prime, it's because I know it's going to go right through the same point. There's no point in doing a third line or a fourth line. The first 2 lines are going to tell you where that point is, and any other line you draw is just going to pass through the same point anyway, giving you the same answer you already had, so it's useless. But there you go. There's our center of dilation. We can see that the ABC is the pre-image, and the A prime, B prime, C prime is the image. We know that this is the image simply because it has the primes in its name. The primes always indicate that that's the image. And so if we're going from big to small, then we're definitely talking about a contraction here. This is a contraction because the pre-image got smaller when it became the image. Now it says tell us the scale factor. Well, we know that to find the scale factor, you just take any 2 corresponding sides and you divide them. The only sides we have are 12 and 6. Now they had us think about whether we're an expansion or a contraction because we know to get the scale factor we're going to divide. Now I could do 12 over 6, or I could do 6 over 12. But since we just thought about how we need to be a contraction, you know that your scale factor needs to be less than 1. So right away, you should be saying, this is not right. I shouldn't be doing 12 over 6. 12 over 6 would give me a scale factor of 2, which would imply an expansion. We're trying to contract. So you know you want to take your values and divide them in the order of small number over big number. And that's going to reduce down to 1/2 for you. So for this problem, we had to do 3 things. We found the center of dilation. We told whether we were an expansion or a contraction. And then we found our scale factor. So we're done. Moving on. So this one says the dilation image A prime, B prime, C prime is an expansion or a contraction of pre-image ABC. Looking at this again, we can see that if this is the original pre-image and we're mapping onto this little guy, then we're talking about a contraction again. Our scale factor would again be either 16 divided by 8 or 8 divided by 16, but if we're a contraction, we better do small over big. So it's 8 over 16. But any fraction you get that you can reduce, you need to reduce. So don't leave this answer as 8 over 16. Give it as 1 over 2. just divide both by 8. Now they actually have questions about lengths of sides. So they're telling us BC is 28. And they want to know how long is B prime C prime. Well, we know that with a scale factor of 1/2, everything is getting multiplied by 1/2. So this length should just be half of whatever the 28 was. And half of 28 is 14. Then they're saying the distance from P to A prime. So that's this little baby distance right here. That distance is 9. So now they're wondering what's the distance from P all the way to A. And again, if our scale factor is 1/2, then 9 is half of whatever this was. And so what number is 9 half of? It's half of 18, right? We can double 9 to find that this original distance must have been 18, which is why half of 18 gave 9. So that's it. I hope that feels pretty straightforward. We'll keep going. So number 5 is really similar. For this one, we can see we're starting on A, B, C, and we end up with A prime, B prime, C prime. We're clearly getting bigger, so this is an expansion. They want to know the scale factor, so we should use the measurements they gave us. They're telling us that the original distance from P to C was only 6 units, and the new distance from P to C prime is 24. So we can see that we have multiplied by a factor of 4 if we divide the 24 by 6. That tells us our scale factor is 4. So that means if BA is 5, then you're going to multiply 5 by 4 to find that B prime C prime is 20. And we can see that if from P to B, actually we're going from P all the way to B prime. So that distance is 28. So what's the distance from P to B? Well, since that distance is smaller, we won't multiply by 4. We'll multiply by the reciprocal of 4 instead. We'll multiply by 1/4. So 28 divided by 1/4 is the same as 28 divided by 4, which is 7. So there's all the answers to number 5. 6, it says find the center of dilation. Okay, we had a rule for that. I think we said find a point, find the image of that point, connect the dots. So if I connect B to B prime, there's a line. Here's F and F prime. If I connect those, well, these lines seem to be mysteriously meeting at point A. And it's not a mystery. Point A is the center of dilation. The center of dilation can be a point that's on the original image. The center of dilation could be inside the image, or it could be outside of the image. It doesn't matter. It could be anywhere. So for our purposes, the center of dilation for sure is point A. Now, given that A, B, C, D, E was our original figure, A prime, B prime, C prime, D prime, E prime, F prime is our new figure, and it's clearly gotten smaller, so this is a contraction. And then our scale factor. Well, we went from a length of 6 down to a length of 2. So our scale factor must be whatever 2 divided by 6 is. So it's 1/3. That's it. So here we're moving on to coordinate notation rules and doing dilations in the coordinate plane and all that stuff. So not a lot really changes though. In terms of answering whether we're an expansion or contraction, again, just figure out who's who. This doesn't have any primes on it, so this must be the pre-image. This does have primes, so this must be the image. So if I'm going from pre-image to image, I can see that I've clearly shrunk, so this is a contraction. And it doesn't look like this guy's going to be centered at the origin. Many of our dilations are centered at the origin, but if I connect a line from A to A prime, from C down to C prime, I'm not getting a point of intersection at the origin. So don't quote me as saying that we are always centered at the origin, because clearly we are not. This center seems to be at 1, 2, and then 1, 2, 3, 4, 5, well, hold on. 1, 2, 3, 4, 5, 6. Yeah. So our center of dilation seems to be at +2, -6, not the origin. Now when they ask for the scale factor, I'm just going to look at a pair of sides. How about AB? Those are both pretty short. and I can find them. So 1, 2, 3, 4, 5, 6. So I'm counting the boxes. That's 6. A prime, B prime is only 2. So again, we've been shrunk down. So don't do 6 divided by 2, do 2 divided by 6, and you get a scale factor of 1/3. Now it says, can you write a coordinate rule? Well, the answer is yeah, someone could write a coordinate rule, but we don't. Remember, the rule was we only write a coordinate rule when we're centered at the origin. So it says, can you write a coordinate rule? We're going to say no, and we're going to say explain, we're going to say dilation isn't centered at 0, 0. And if it's not 0, 0, then you don't have to write the rule. If so, write it. We'll say not applicable. So we don't have to. Now, number 5, this one, I bet it's centered at the origin, and I bet we're going to have to write our rule. So again, we're going from little guy to big guy. So this is now an expansion. The center of dilation, if we draw our nice, perfectly straight lines, then we're going to go from C prime through C. You can already see that going through the origin. We're going to go from A prime to A. And you can see that going through the origin. And so that is our point of intersection at the origin. So this one we will be able to write a coordinate rule for. So this is 0, 0. To find your scale factor, just compare some lengths. I see another just vertical line with length 2, so I'm going to use that. I see another corresponding vertical line over here with length 1, 2, 3, 4, 5, 6, 7, 8. So that's telling me that all of our measurements have been blown up by a factor of 4, so that's our scale factor, 4. It says, can you write a coordinate rule? We're going to say yes. Explain, we'll say 0, 0 is the center. So now, writing the rule is very easy. You just have to memorize the form of it. The rule is always going to be that xy maps onto k times x and k times y, where k is whatever our scale factor is. So that means the rule for the problem we're doing right now would be that the original point xy maps onto the new point whose coordinates are 4 times x and 4 times y. And that's it. Really easy. You just take your scale factor and you multiply x by your scale factor, you multiply y by your scale factor, that gives you the new form of your coordinates. And that's it. I think that's it for this whole homework, right? Yeah. So that's it for page 112. You can watch the next video for 116. See you guys in class Monday.